This video is about solving equations containing radicals. I've given you the steps here. The first thing you want to do is isolate the radical expression that occurs on one side of the equation. You want to raise each side of the equation to a power that is the same as the index of the radical. This will eliminate the radical. If the equation still contains a radical expression, repeat steps 1 and 2. Solve the resulting equation. Check each proposed solution with the original equation. Remember, always check solutions. It's vitally important that you do that with these kinds of equations. All right, we're looking now first at example 1. So I have x minus the square root of 4x plus 12 equals 0. So step 1, we're going to isolate the radical. So what I'm going to choose to do is move the radical expression to the right. So that's x equals the square root of 4x plus 12. Now, the instructions said from there, square both sides. So I'm going to square because what I have is a square root. Remember, the index of the radical and the power used must be the same. That'll give me an x squared, and then squaring a square root will give me the 4x plus 12, which is the radicand. So what I'm doing is I'm converting this equation from a radical equation to something that we know how to solve easily, and this one in this case is going to be a square root, a a quadratic. So I've got a x squared minus 4x minus 12 equals 0. We've got all kinds of methods to solve a quadratic. I'm going to use the factoring zero factor property technique because it works and it's easily factored. Okay, so I'm going to choose those factors. I'll set each factor equal to 0 and solve each one. Now notice we get two solutions. We get an x equals -6 and we get an x equals -2. That is a result of solving this quadratic. The original equation though, however, you see is not quadratic at all. So what we've got to do is check our solutions. So first off, I'm going to check x equals -6. So that's going to be, let's go -6. Let me erase that. I've got a -6 minus the square root of 4 times -6 plus 12 equals 0. So that's -6 minus -24 plus 12. So that's -6 minus the square root of and I'm mistaken. This is a plus 6. So let's fix that. Sometimes I make typographical errors, but I'm not typing. So that's a 36 equals 0. So that's 6. The square root of 36 is 6. So that's going to be 0 equals 0. So that solution works. So then I must check the other. So I have -2 minus the square root 4 times -2 plus 12 equals 0. Now sometimes both solutions work. Sometimes one of them doesn't work. Sometimes none of them work. So that's going to be what? A positive 4. So that's going to be -2 minus 2. -4 equals 0. We know that that's a false statement. So we have to throw out that solution as extraneous. It's an extraneous solution. It's a result of the quadratic. It is not a final solution to the radical. So our lone solution then is the solution x equals 6. All right, moving to the next equation, notice I have two terms with radicals. Just a little different twist. I am going to choose to leave the square root of 3x plus 1 on the left, and I will move the square root of x plus 4 to the right by adding. So then what I'll choose to do then is square both sides. Now this is vital that you do this correctly. So that gives me a 3x plus 1 on the left. Now remember, if we have an x plus y to the second power, that's the same as x plus y times x plus y. And you've got that little formula, if you remember it, that'll get you a 2 times xy plus the y square. So, in other words, this is the formula that your binomial to the second power will follow when it's multiplied out. So using that formula, I've got a 1 matches the x, so that's a 1 square, which is 1, plus, then I'm going to go 1 times square root x plus 4, which is square root x plus 4, and then I have to double it because the formula says to. It's just how it works out when you multiply out. And then the y matches the radical, so when I square the radical, that will get me an x plus 4. It's just a quicker way around it as far as getting those solutions. Okay, and if that bothers you, then go ahead and multiply this out. That is a y. Actually, that is a 4. And you'll get the same result using that technique. It just takes a little bit longer. Whoa, don't know what happened there. So now I'm going to combine like terms. I've got an x over here with a 3x. I'm going to subtract. That'll get me a 2x. Okay, if I subtract 1 from both sides here, those will add to 0. And then I can bring the 4 over. I kind of cheated collecting like terms. Of course, this is a 5. And then if I were to subtract 5 from both sides, I would indeed get the negative 4. Okay, so now notice we still have a radical. So notice additionally that I have a factor of 2 outside here. I could simplify that a little bit to make my numbers stay smaller by dividing both sides by 2. So then I've got this. Okay, so just shrinking my numbers. Now I'm going to square both sides again. So that'll be x squared minus 4x plus 4. Remember, I'm squaring a binomial. And then I'll square the radical. So I've got x squared, bring the x over here, minus 5x, minus 4x on both sides. That will zero out. So I'll factor this using my greatest common factor technique, so that x will equal 0 or x minus 5 will equal 0. So I have two solutions here, okay, as a result of the quadratic here. Notice my original equation is not quadratic at all, so I must check my solutions. Okay, so I'm going to start with x equals 0. So I have, and you don't have to write every step. You can pretty much eyeball things in and do a lot of this in your head, but I do recommend writing a little bit. So I have 3 times 0 is 0, plus 1 is 1, so that's square root 1 is 1. That's square root 4 is 2 equals 1, and that's a negative 1 equals 1, which is certainly false. So that means we cannot use that solution. It's that cute little word we've been using, extraneous. Okay, better change the ink color there. Now that does not mean the 5 works, we just have to check it, because it may not. It might or it might not. So I have the square root of 3 times 5 plus 1 minus the square root of 5 plus 4 equals 1. Okay, so this is going to be 15 plus 1 is 16. That's square root of that is 4. This is square root 9, which is 3. That's a 1 equals 1. That's valid. So I have one single solution that works for my equation, and that is x equals 5. All right, we have a little different twist here. What you notice here, we have cube root equations. We'll use the same technique. We want to isolate radicals on one side or the other. So I'm going to choose to move this term to the right. Okay, makes it positive and makes it a little bit nicer to deal with. Now, since I'm dealing with a cube root, I'm going to cube both sides. That'll get me a 5x squared minus 12x plus 6 equals x. That's 5x squared minus 13x plus 6 equals 0. All right, I always run to the general standard form first because it just might factor, and I'm generally going to try that out just in case because it's easier than the quadratic formula, and maybe probably in this case a little easier than completing the square. So I need the factors of 5. I know I only have one pair of those. I know I'm going to have both subtraction. So the factors of 6 are 1 and 6, 2 and 3. I'm going to choose to try the 3 here and the 2 here. So notice this times this gives me 6. This gives me negative 10 minus 3 is 13x. So using that zero factor property, okay, I have two solutions. The two solutions, again, are a result of the quadratic equation. Now, using those two solutions and then having to check these, and we do, what I've done is made it an additional slide, okay? So the first thing I'm going to do is check x equals 3/5, and you should not panic. This isn't going to be as bad as you think it is. So I have 5 times 3/5 squared minus 12 times 3/5 plus 6 minus the cube root of 3/5 equals 0. Now don't go run to a calculator. You can algebraically manipulate this. I have 5 times 9/25 minus 36/5 plus 6. I'm going to leave this term. Okay, see how things happen. So this will simplify to a 9/5. So I have cube root of 9/5 minus 36/5. And then that's going to be plus 6. I'm going to drop down here. And that is going to simplify to negative 27/5 plus, I'm going to take that 6 and call it 30/5. And the really cool thing is negative 27 plus 30 is 3/5. So I have cube root 3/5 minus cube root 3/5 equals 0. And in fact, it does work. So we have a valid solution here. Now, the other solution that we're going to check is x equals 2. I believe that's the one. Yeah. So I have x equals 2. So I have cube root. So I've got 5 times 2 squared minus 12 times 2 plus 6 minus cube root 2 equals 0. Don't run to the calculator. This is very easy to manipulate. So this is going to be squared. That's going to be a 4. 5 times 4 is 20 minus 24 plus 6. So this is going to be minus 4 plus 6 on the cube root. So that's going to be cube root 2 minus cube root 2. Well, that's 0. How wild is that? So you didn't even need a calculator to manipulate those. So indeed, here you have two solutions. One is 3/5 and one is 2 for this cubic equation. All right. The next to the last one that we're going to do is how we deal with the rational exponent. There are two methods. I am going to show you both. You can use either one. When I encounter a problem like this, I immediately run to the radical. So that's going to be square root x to the third power equals 216. Now again, that's what I do. So let me rewrite this step, because then what I'll do, since I'm raising this side to the third power, then I'm going to take the cube root of both sides. When I do that, that'll get me x equals 6. The cubed root of 216 is 6. You can test that out if you don't believe me. Okay. And then this is still square root. Okay. So the cube root 3 and the third power are inverse operations. They undo each other, so it does leave square root. Now what I need to do is get rid of the radical by squaring both sides. That'll give me an x squared equals 36. Actually, not x squared. That will just get me an x, sorry, equals 36 as my solution. All right, and when you check it, I've got 36 to the 3/2 power equals 216. Now for me to evaluate this without a calculator, I'm probably going to run to the square root 36 and then raise it to the third power. And that's going to be 6 cubed, which is 216. So that's valid. So that is my solution. There is just one. So that's method 1. Method 2 looks like this. I am leery of this method because sometimes you'll need to include the plus or minus over here when you're taking square roots or roots to even powers. This method, it makes it very easy to forget that. But this is how you do that. So we're going to think raising a power to a power, and we want to create a power of 1. So since I know I multiply these, then I need to raise that to the 2/3 power. Need to do that to both sides. These, of course, multiply to 1, which it looks easy right now, and you go, oh, well, that just gives me x. But I still have 216 to the 2/3 power. Now, that is not a simplified answer, so I have to think, okay, I need cube root, because see, my problem changed. Now, I can either square the 216. I don't think I want to do that since I'm going to try to figure this out in my head. Or I'm going to square it there, and I think that's going to be the easier road to go. I do know the cube root of 216 is 6, and I know when I square that, I do get 36. So just an alternate method for solving that kind of equation. All right, let's do one more. This one has terms. All right, I'm going to use the method I like and I prefer. So that's going to be the 5th root of x plus 7, and that's going to be raised to the 2nd power equals 4. So I'm going to focus on the 2, that 2nd power, and I will take the square root of both sides. This is what I warn people against using that other method. This is likely to be forgotten, and it will lead to an incorrect solution. So the square root undoes the square. That'll leave me the 5th root of x plus 7 equals plus or minus 2. All right, now I need to raise both sides to the 5th power. That'll give me an x plus 7 equals, now I'm going to have a positive 2 to the 5th, or I'm going to have an x plus 7 equals a negative 2 to the 5th. I have to consider both. So that's x plus 7 equals 2 to the 5th power is 32, and I'm going to subtract 7 from that and get 25. So over here I'll have plus 7, that's going to be a negative 32, subtracting 7 from both sides will get me a negative 39. And of course when you check those, and you should because these are radicals now, I'm going to have 25 plus 7 to the 2/5 power equal 4. So 25 plus 7 is 32 to the 2/5 power. So I'm going to think about that as the 5th root of 32 squared, which is 2 squared equals 4. So that's a valid solution. It's true. And then the other number I will check is -39. So that's going to be the 5th root. Actually, I want to do that a little differently. Okay, like I did the other. So I'll have -39 plus 7 to the 2/5 power equal 4. So when I do the arithmetic here, that'll give me a -32 to the 2/5 power equal 4. Then we can convert that to the 5th root of -32 square. Let me make that look a little better as well. Square equals 4. And again, I'm just rewriting the left side. Well, the 5th root of -32 is -2. Squaring that, we get a 4. So that works as well. So we have two solutions for that particular radical equation. So that is the end of this PowerPoint slide.